finding the standard deviation, like,
Um,
'cause that's in the textbook.
no, it's the distribution or the probability one. I don't know. He like made a recording and he said like this Excel sheet's online and I just can't find it. So I don't know. But maybe it's not necessary for this quiz.
Yeah. There's another way to do standard deviation on Excel also. That's really easy. If you just do equals STDV, it'll calculate the standard deviation.
Equals SDV?
Equals STDV. I think so. Let me.
Yeah, that is.
Okay.
Okay.
Just put in the numbers and then do the standard deviation of those numbers.
Are you going to go to the reception in Fresno? Unfortunately, what? You can go to California, Bryson. You go to vacation to California.
Okay, so we have to also do part 2 of our individualists.
Well, it's not the best part. The best part is
Of our the preparation thingies.
Yeah, do we have to do that together? That said with a group.
Yeah, it did. Open mine.
Wait, we have to do what?
Yes.
Preparation assignment part 2 said that we should do it as a group.
Because we have a list of songs for Casey now. Now we just have to make a list of songs for you. Would you rather do like pop songs?
I can read number 5 when you're ready.
Okay.
An 8-sided die has 8 possible outcomes for each roll, 1 through 8. Calculate the probability of rolling a number greater than 5.
Definitely those two.
I was thinking greater than 5 would be 6, 7, and 8. So that
Wait,
would be 3 out of 8 on the homework assignment.
Oh,
Sorry,
okay.
part 2.
Okay, I was looking at the quiz.
And I don't know if it's just meaning that we're talking about it and recording it, because I don't know how else we turn that in.
Yeah, I guess so. It just said do it with your group. So, I mean, it's pretty simple, but yeah, that's good.
Yeah.
So yeah, I would say that too. 3 out of 8.
And then calculate the probability of not getting a number greater than 8.
So not greater than 5. So it would be 5
Yeah.
and less. Yeah,
5.
5 out of 8.
5 out of 8. Cool. Good job, guys.
I just didn't really think we had to do it with a group.
Oh, well, I said it, so I figured we might as well do it.
Okay.
Okay, so
That'll be so good. We will do that tonight for sure because we have to.
I can read number 1 if you want.
Okay.
Or 3, I guess. Okay, so human blood can be classified into one of our 4 basic types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following tables below, or tables. The blood types and the proportions given in the table above define a probability distribution. So,
Yeah. Right now. Until what time? Sorry.
5. True?
Yes, because they all add up to 1.0.
Yeah, that's what I was calculating, yeah. I can't remember the other 2 rules.
Yeah.
The last rule I didn't really super understand too well, but I'm guessing true.
So do you guys understand what a probability distribution is?
Yeah.
What's your goal? Oh, sorry.
I think so.
Okay, so I can explain the third rule. Okay, so did you see in the textbook where it was talking about probability distributions?
I'm not talking about the rules, but I'm talking about like the definition of the probability distribution itself.
That's what it is. So like, for example, in this question, this is how it's distributed in proportions. So to have a blood O type of 0.45, or to have one, and then the probability of having A is 0.4. So that's the distribution. So basically, they take the probability and they put it into a fraction that equals 1. And so if you read the rules, the probability of something happening is, the first rule is that the probability of something happening is between 0 and 1. So if you have like a 6-sided die, or I'll just say 5 because it's an easier number to divide. You have a 5-sided die for whatever reason, and the probability of you rolling a 1 would be 0.20, and the probability of you rolling a 2 would be 0.20, and like so on. And basically, if you add them all together, it would equal 1.
Mm-hmm. Can you
And
explain
so
the last one?
the last rule.
Yeah, I thought that's the
So
one I was
the-
kind of confused
yeah.
on.
So the probability, let's say you have this 5-sided die again, and it says, what's the probability that you will not rule a 1? So the probability that you will would be 0.20. The probability that you wouldn't would be 1 minus 0.20. So probability that you wouldn't roll it would be 0.80.
Oh, okay. That's, yeah.
Yeah.
That's super. Okay. The words,
Yeah,
I was
it's-
like,
Yeah,
huh?
I think it's confusing how it was worded.
Yeah, it was
Yeah.
way weird word. Okay, perfect. So true. We got true on the first one, or 3. Sorry.
Does that make sense to you? Or-
Yes, I just didn't understand the terminology. Yes.
I know, me too. I was like,
Yeah.
weird.
Yeah, so the chance that you'd roll any number on the die would equal 1.
Okay, perfect.
Yeah.
Yeah, I understood that one. That would make sense. For number 4, who wants to do it? Read it.
I can do it. No, never mind, go ahead.
What is the probability that a randomly selected person in the United States has type O blood? Round to two decimal places. So on that chart, it says it's 0.45.
hmm
Yep, that's what I got.
And I think that was the answer.
Yeah, that makes sense.
That's too easy. It's just reading a graph.
I know, right? So
I'm like,
easy.
this lesson, I can do this one.
Yeah. All right, next person.
I'll do the next one. What is the probability that a randomly selected person will not have type O blood? Talking about with the rule. So it'd be 0.55.
Yes.
Yep.
Okay.
I'll start reading for question 6.
Okay.
Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
So it's just 1 divided by 7.
6.
Okay, 7. Are there 7?
Or there's 7, yeah.
Because there's 7 bowls.
0.143.
So 0.143. Mm-hmm.
One time when I was on iLearn, it just had trouble taking the answer if you didn't put a 0 before the point. So I just thought I'd mention that if you guys want to do that.
Okay.
That's a good idea. I will do
I'm
that.
sorry. Mine kind of froze. What did you say?
In the past, when I was taking a math class online, when I didn't put the 0 before the 1 in my answer, it said it was wrong. So you can
For the decimal,
Okay.
right?
put the decimal, like 0 point whatever it is. So
That's a good idea.
mention that.
Yeah, I
Just like
added it. Back to me. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very likely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer, and this is little evidence that dogs can detect bladder cancer.
I think it'd be strong.
Yeah, because it said it's very unlikely. I don't know.
Yeah,
Yeah.
I don't know what
'cause it said it would be
percent has to
unlikely, too.
considered. Yeah.
Okay.
yeah.
It's very unlikely. Yeah, especially if they're like unlikely to do that by random chance.
Yeah, I don't know if there's like a math equation to be able to figure that out, but it says it's unlikely that they figure it out
Yeah.
by random chance. So,
Oh, okay.
okay, wait, is my turn to read? No, it's not. Never mind.
Angie's turn.
It's my turn. Okay. My favorite M&Ms. M&Ms are small chocolate candies. Oh, we already did that. Okay. So if you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy?
Oh,
So it says red is 0.13.
so wait,
Yeah.
you, Bryson, is the first
That
chapter.
would be the probability. That's too easy.
Yeah, that I know. It's so this is easier than last
I
week's. I feel like.
know.
Okay. 1 minus. Okay. What is the probability that a randomly selected candy is green? 1 minus
26.
0.13 is 0.14.
Point
0.16.
16. Yeah.
Okay. You guys all good on that?
Yep.
Okay. Awesome.
Ooh. That's not what we do. Hurry. Finish the first chapter.
Turn is it?
After by Frank. Yay! Let's make yourself a deadline. Nice.
Oh,
I remember my creative writing class. Our teacher said,
Turn is it to read?
I think is it
"No, it's not writing lots of realistic fiction."
Elena? Is it your turn?
Is it my turn?
Yeah, I think so.
Okay, I didn't realize that. What is the probability that a randomly selected candy is not green? Round to 2 decimal places.
Two is 7. Yeah, it's been pretty.
See it. 0.84.
Yep.
Okay.
Yep.
It's fun though.
All right, back to my turn.
Yep.
Okay, so the ACT scores of students admitted to a medium-sized public university in the Western United States were taken. Okay, whatever. Half of the observations are less than or equal to what number?
4.3.
Less
So-
than or equal to.
No, never mind. That's the standard deviation.
So we need to do
So
24.
So would it be the median?
24.
24. What'd you say?
I think
Yeah,
it
I
would
was
be
asking if it
24.
was the median. Uh-huh.
Yeah, 24. I think so too. Good.
But isn't the medium the middle number in like the range?
Yeah.
It's
So we're
less than or
it's
two.
sorry.
No, but I'm so jealous. I'm not
No. I'm just like if we had a range of like 5 numbers, like 1, 2, 2, 9, 10. The middle number would be technically 2, but that wouldn't make half of the opposite observation or equal to it.
So I'm getting that confused with mean. So
Yeah.
do we know? Oh,
That
the
would
mean
be
is
half of them.
24.3.
Well, because it would be half of, because it's the middle number, so we know that this half is equal to 24 or less, and then this half is either equal to or higher than 24.
That's awesome.
Does that make sense?
I think so, but I could be persuaded if it's not right.
Wait, are you thinking that it would be mean?
No. I'm saying that 24.
No,
Oh.
sorry, not you.
Okay.
But
Elena.
I'm horrible with names. Elena, thanks. So are you saying you think it would be the mean instead of the median?
I'm honestly not sure. I'm not sure how we could figure out that.
Okay, so the mean would be the average out of all the numbers. So if you had like 1, 2, 2, 9, and 10, the mean would be higher than 2 because of those two outlying numbers on the higher end.
Mhm.
But if you were to divide the numbers in half, because observations would be 1, 2, 2, or 2, 9, 10,
Okay.
the median would be what you're looking for. And so what the question is asking is for half the observations.
Okay.
Yeah.
Well, that's very accurate.
All right. Everyone clear on number 11? Good to move on?
Yeah.
Okay.
Is it my turn to read again?
Maybe.
I think so. You go.
Based on the information on the table above, the top 25% of the students scored above what number?
27?
27.
That's so
That's what I thought, because Q3 is 75% of
Yeah.
Yeah, so that would be, yeah.
the data.
Yeah. Wait, just to confirm, median is the second quartile, right? Not mean?
Right.
Okay. Just double checking.
So quartile 3.
Yes.
I went
Yeah,
back to read
median.
it just because.
Okay. Okay, which of the following statements is not one of the 3 rules of probability?
Oh, we know these. Keep going, sorry. Is it?
Sorry, okay.
What?
I think it's the third one. If the probability is high, then the probability is positive.
Yeah, same.
If the probability is low, then it's negative. Yeah.
Yeah.
Not one of them.
Perfect.
You guys are all good? Okay. I guess I'll submit. And I'll let you guys know.
Okay.
Yeah, because we each get like 2 chances, so if I'm
Yeah.
wrong, it's not like I can't go back. Yeah, well, you got 100%. We're good.
Yay.
Okay.
Perfect. That was nice and fast, guys.
That was really quick. Awesome, because I have to get my laundry.
Thanks for explaining things.
Questions?
No, just that for some reason that was just like the way it was worded. I'm just like,
It was really weird.
Yeah.
this mean? Okay.
Yeah.
All right, perfect. We'll see you guys on Wednesday, and I'll go and submit this.
All right. All right.
you.
See ya.
Okay, bye.
Bye.